Read the question carefully. Here we need to set up a triple integral. So basically triple integral whose value is the volume. So volume means the function should be 1, just 1, dv. Okay, of the region, and we have some solid E there, by the way, under the plane given by this and above the region in the xy plane, bounded by the graphs of these two curves. These two curves live on the xy plane. And if we graph them, so y equals 3x, straight line, y equals x squared minus x, this curve, they intersect at x equals 0 and at 4. In fact, we can solve this just by algebraically, because 3x equals x squared minus x, x squared minus 4x, x factors out, so from here x 0 and 4. So that's what we get if we graph this correctly. Now this triple integral is always same as we have the region D, that's this region, and we have bounds for G, function is 1 dg, and outside in terms of area, change in area, dA. Okay, and the bounds for G are, this is above the xy plane. Okay, that means the lower bound is 0, and below this curve, so we have the curve x plus 2y minus z equals 0. That means move z over, so x plus 2y equals z. So this is the upper bound for g, x plus 2y. Now we essentially reduce this problem into a double integral where D is this region. Now we have two options. We can take this as type 1 or type 2, and if we go here from in this way, vertical line, to get here, lower curve is x squared minus x, upper curve is 3x, and this arrow could be taken anywhere from 0 to 4. That's in the x direction, and this is y direction. So we can make it a type 1, or you can go for type 2. Now type 2 would have been, look at the very bottom here, we have a shape like this, and when we go type 2, that means we are taking horizontal arrow that would go from one curve to the same curve, not to the other curve. So type 2, we have to be careful. That means Ax goes all the way last, and Ax, this arrow 0 to 4, Ax 0 to 4, and y lower curve x squared minus x to upper curve 3x, and we already figured out for the g equals 0 through x plus 2y 1 dg, and this is dy dx, by the way, this dA dy dx, and we can easily evaluate if we have to, but in this question we just leave here final.